and welcome to today's episode of One Man and His Whiteboard. Today we continue in our conversation on IP subnets. This is part 4, calculating subnets. So what I wanted to do is I wanted to give you a formal process for doing the calculations that we require to do with regards to subnets. I took the liberty in this situation of typing things out ahead of time because it's a little bit boring for you to watch me type things and try and write them with my a mouse, as it were. So I've actually pre-configured a lot of information, but now what I want to do is I want to talk you through it. So let's say we're given an IP address of 172.16.4.17, and we're told the network mask is 255.255.255.0. I want to show you a process to calculate the subnet address, calculate the host portion of that address, calculate the first and the last host numbers within that subnet range, calculate the broadcast mask, and then how we easily identify what the next subnet would be. So here's a set of instructions. I'm not going to read through these now. I'm going to go through these on the next few pages and show you the process in action. So it's a simple 9-step program to calculate what you need to calculate for subnetting. Also, pay attention on the side, I've got some notes. Note number 1 defines the class A, B, and C. Our first byte number ranges. Note number 2 defines the byte to bit values. I kind of spread them out. And note number 3 defines the standard network mask for a standard class A, B, and C. So let's do this. So first of all, determine the IP address class using note number 1 on the left. Well, it's a 172 dot something. 172 is within the range 128 to 192. Therefore, it's a class B address. Now convert each of the decimal portions of the IP address to binary using the information in note number 2. Obviously, if you have a binary calculator, that's going to make this a lot simpler. So 172, 16, 4, and 17 are shown as their binary equivalents there. Now, it's very important to line up each of the bits within each of the bit positions. As I mentioned to you before, I like to split the bytes out into 2 lots of 4 bits because it makes them easier to manage. Step number 3, convert the network mask to binary using the note number 2, 255.255.255.0. As you can see, we've done that there, done that here. Now write down the IP address class mask that you've gotten from note number 3 and convert it to binary. Well, a class B is 255.255.0.0, so convert those bytes into binary. You might think, Phil, this is a little convoluted. I know what 255 is, I know what 0 is. But trust me, this is the easy example. In the next section, we're going to do a more complex example where we don't have a 255 mask. So if you follow the procedure, once you've mastered it, then you can take shortcuts. So now what I want you to do, I want you to line up the binary you've got thus far on a sheet of paper. So I've written down 172, 16, 4, and 17 in binary, the IP address. Then I've written the network mask in binary. Then I've written the class mask in binary. Now, what you simply do is you look at this and you see where the network mask and the class mask differs. Highlight that, and I've changed the color to red, and I've highlighted it with a yellow border. That's where the network mask and the class mask differ. That is the subnet. Now what I've done is I've written the number from the subnet field above. It can be quite confusing why I've done this and seems a bit pointless, But what you do is you write down the number that's highlighted in red, and any leftover bits that are in the host field, you pad out with a 0. Now in this example, we are using the entire byte as a subnet, so there are no leftover bits. But you'll see in the next example why this step is very important. So we've identified everything to the left of the highlighted section is the network 172.16, the class network. What we've highlighted is the subnet field. Everything to the right is the host field. So 172.16 is the class network, 4 is the subnet, 17 is the host. And it's quite common to say 172.16.4 is the subnet. So now what we do is we write down the IP address up to and including the subnet field 4 times, exactly the same, line 1, line 2, line 3, line 4. In the host portion now, and I've done it here in purple, we write all zeros on line 1, then we add 1 to it for line 2. We skip down to line 4, we write all 1s in the host field. Then we subtract 1 for line 3. Now you convert these numbers, the entire 24 bits, back into decimal, and what you have on line 1 is the subnet address. Remember, it's convention to zero out the hosts when talking about a network, so 172.16.4.0 is the subnet address. Line 2 gives you the first available host on that subnet. Line 3 gives you the last available host on that subnet. And line 4 gives you the broadcast address for that given subnet. Now look at line 1. Identify the subnet component. Add 1 to it, and that is the next subnet address. So in this instance, we're adding 1 to this bit position here. So 172.16.5.0 is the next subnet. Now because we were using a 255 mask, the subnet extended all the way over to the 1 bit position. So a shortcut here, the rightmost bit in the subnet field, identify that bit, then look at what that bit represents in note number 2. So in this instance, all the networks go up by 1. So a shortcut here, the subnets increment by the rightmost bit position of the subnet mask field. So because we have 255 with 8 bits, we go all 8 bits over to the right, so the subnets go up in 1s. Nice and simple. This might sound very unexciting now, but in the next example, you'll find that is a really, really quick way to see what your subnets are. That's it. That's the process. The beauty of video is you can watch it again, you can go back, you can take screenshots and write down this process. That is the process to identify a subnet from a network number. You can then identify the first and last hosts. You can then identify the broadcast address. And this is a useful little tool as well, by the way. Once you've mastered this technique, you can see, given a subnet, how many possible hosts can we have on that subnet? Now remember the golden rule, you never have all zeros or all ones in any field. So because we are using the entire byte in this instance, we have 256 different decimal numbers. You can't have all zeros, can't have all ones, so we have 254 possible subnets using the entire byte as a subnet field. We then have 256 possible hosts. You can't have all zeros, you can't have all ones. Why? Because the zeros represent the subnet address, ones represent the broadcast address. That's the reason why. So you can only have host 1 through 254. So 254 available hosts. Okay, that's us done. See you next time.